Let's work out this example of implicit differentiation using the cardioid as our equation. In here, what we want to do is we want to first find the derivative of the cardioid and then use this information in order to write down the equation of the tangent line. Notice how first we need to understand that in this context, derivative might mean dy over dx or dx over dy. Using either of these will give us the answer. So let me just focus on dy over dx because traditionally that's the one that we use. However, if we do dx over dy, we would arrive to the same answer. So the first thing I want to do is I want to take the derivative of this expression, meaning I want to do dy over dx using the chain rule. If we start doing this, I will get on the left-hand side 2x squared plus y squared plus x times the derivative of the inside, and this will give me our dy over dx. So let me use dy over dx in this context so we can see the difference, plus 1 equals, and then the right-hand side, that will give me just 2x plus 2y, and again, because of chain rule, we will have dy over dx. Now the point is to expand this expression and collect dy over dx. So we want to solve for this. So what I'm going to do is I'm going to expand this expression algebraically, and then I'm going to collect dy over dx. If we do that, on the right hand side, we can multiply these terms together. We will have, first of all, 2x squared plus 2y squared plus 2x times 2x plus 2y dy over dx plus 1. And then on the right hand side, I'm just going to copy the same thing that we had before. Now let's multiply the first two parentheses on the left hand side. We will get 2x cubed plus 4x squared y dy over dx plus 2x squared. Now I'm going to get plus 4xy squared plus 4y cubed dy over dx plus 2y squared. And then finally, I'll get 4x squared plus 4xy dy over dx plus 2x. This is only on the left-hand side. My right-hand side still stays the same. Notice that I have 1, 2, 3, 4 terms that actually have dy over dx, so I need to collect all of this. What I'm going to do is I'm going to write them down on the left-hand side, and then everything else I'm going to collect on the right-hand side. This means that the first term is going to be multiplying dy over dx as a common factor. For the first term, for x squared y plus 4y cubed plus 4xy. So those are the ones coming from the left-hand side. And the right-hand side, I will have a negative 2y. So those are the 4 terms that involve dy over dx. Then on the left-hand side, I'm going to move everything else, everything that I have not collected yet. So starting from the top, I'll have minus 4x cubed minus 2x squared minus 4xy squared minus 2y squared minus 4x squared minus 2x. And then I just had one term on the right-hand side that didn't have a dy over dx. That one remains positive. So now this is the expression that I'm looking for. Then what we can do is we can simplify the right-hand side and then divide by that coefficient on the left-hand side. Meaning, if I solve for dy over dx, we can simplify the expression on the left. In other words, notice that we can cancel the negative 2x with the positive 2x. We can put together the negative 2x squared with the negative 4x squared, and that's pretty much it. So the numerator in here will have negative 4x cubed plus 6x squared, putting negative 2x squared and negative 4x squared together, plus 4x squared, y squared, plus 2y squared, and then the negative 2x and the positive 2x cancel each other. Notice how we took a common factor negative in here, so we can write down everything with a plus. Now we just divide by the coefficient of the dy over dx on the left hand side, and this will give us 4x squared y plus 4y cubed plus 4xy minus 2y. Notice that we can simplify this a little bit more if we cancel a factor of 2 on the top and the bottom. And this will give us dy over dx being equal to minus 2x cubed plus 3x squared plus 2xy squared plus y squared divided by 2x squared y plus 2y cubed plus 2xy minus y. And this is going to be the expression for our derivative dy over dx. With this, we can actually find the derivative or the slope of the tangent line at any given point. In our particular case, we're looking for the value of this at the point 0, negative 1, meaning we want to plug in x equals 0 and y equals negative 1. In this particular case, that will give us 2 times 0 cubed plus 3, 0 squared, plus 2, 0 times negative 1 squared, plus negative 1 squared, divided by 2 times 0 squared times negative 1, plus 2, negative 1 cubed, plus 2, 0 times negative 1, minus negative 1. If we compute this, that will give us that the slope at the tangent line in this point is going to be, we only have a positive 1 on the top, and on the bottom we will have negative 2 minus negative 1, which will be negative 1 on the bottom, and that gives us a positive 1 overall. So in our case, we have that the slope of this tangent line is positive 1, and we have that it goes through the point x0, y0 equals 0, negative 1. So we can use the point slope formula in order to get the tangent line at this point. So we have that the tangent line equation is going to be given by y equals our slope, which is 1, x minus x0, which is 0, plus y0, which is negative 1. In other words, our slope is going to be, our equation for the tangent line is going to be given by y equals x minus 1. And we can have the graph of this like that. We have that the cardioid is that relationship graphed in red, and in the particular point that we're looking at, the 0, negative 1, we have that the tangent line is given by this dashed line over there.